Hello, I'm Rod Elmore, and today we're going to cover the 6 trig functions. And up to this point, what we've learned is, we've learned that the functions, like for example, the sine of x equals the opposite over the hypotenuse. Now that's not a function, that's just our definition for what sine is related to a right triangle. Now we want to change that into a function, so this value that you get there, we're going to change that into f of x. So now this is a functional relationship with these values being the output and the input being whatever we use for our angle. So now what we want to do is be able to graph that, and then we can look at that relationship. Now to graph that, we would use a typical, and you should be able to do this by hand. We're going to do it on our calculator, but you should be able to do this by hand, because it's important that you can visualize this, because a picture is worth 1,000 words, and this graph, to me, explains everything. When I think about this graph, it answers a lot of the questions you're going to be asked in this class. So now we have to think of what do we want to have for our input, and we're going to use 0 to 2 pi. Now we could go 0 to 360, because we realize that 2 pi is 360 degrees, but usually we use 2 pi. So halfway would be pi, and a quarter of the way would be pi over 2, and this would be 3 pi over 2. So now we have our inputs that we're going to put in. Now what is the value of the sine for each one of these inputs? Well, we've kind of seen already that it's going to go from +1 to a -1. So now what we want to do is to graph this sine function and then see what we can tell from that graph. So if we plot this, I know that the sine of 0 is 0, and the sine of pi over 2 is 1, and that kind of gets me started because it's going to be a nice smooth curve, so it's going to be here. Now what I'm doing now, you should be able to do, make a quick sketch on your sheet of paper to answer a lot of questions. So now we're not going to plot points, we'll let our calculator do that later, but the sine curve is going to look like this. So now when you look at this, what do you see? If all you see is a wiggly line, then that's not good enough. What you can tell here is you can answer a lot of questions about the sine curve. Now my little example here, we're going to kind of move that up there to the top, just so it looks a little bit better. And that's our 1. But now we can look at this, and what do we see? Well, let's see what I see. Now if we think about the quadrants we already talked about, where are those quadrants? Let me mark those just so we can see them clearly. This will be the first quadrant, 0 to 90 or 0 to pi over 2. This is the second quadrant. This is the third quadrant. And this is the fourth quadrant. So we've already talked about how to remember where the sign is positive or negative. So we can look at this and we can see it right in the picture. So we did kind of, somebody came up with all students take calculus to remember where the functions are positive and where they're negative. But here, we can just look at this picture and find out. When you look at the picture here, the sine value is above the x-axis, so it's positive in the first quadrant. It's positive in the second quadrant. It's negative in the third quadrant, and it's negative in the fourth quadrant. So if we want to know where the sine is positive at, we could go with the intervals from 0 to pi is where it's positive. Now where is the sign negative at? Pi to 2 pi. We really should have this be inclusive here, although it's kind of neutral there at the end. So that tells us now, if you were asked the question, what is the maximum minimum value for the sine? Well, you can see the maximum minimum value because the maximum value for the sine is 1, and the minimum value is a -1. So you can see all of that from the graph. Now you can see which intervals is the sine increasing at. Think about that a minute. What intervals is the sine increasing, getting larger? Well, let's see. Sine is increasing in what intervals? Well, it's going up here. It's getting larger. That's increasing. So it's from 0 to pi over 2. And then where else? Well, it's decreasing here. It's positive, but it's decreasing. It's decreasing, getting smaller values. And so then it's increasing also in 3 pi over 2 to 2 pi. So you can see where it's increasing at. And then likewise, where is it decreasing at? All the way in that interval. The sign is decreasing from pi over 2 to 3 pi over 2. Pi over 2 to 3 pi over 2. So we've found that out. The maximum, the minimum, the intervals in where it's increasing and decreasing. And so we can look at that so we don't have to try to memorize it if we can visualize the picture. But the picture tells you an awful lot about the sine curve. And if you think when you look at the sine curve that this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. And we know all about it in the first, second, and third. So let's just kind of take a look at one of our examples. Let's say we want to look at this, and we know that the sine of 30 degrees equals 1/2. From our little table, we learned that. So this is something you should have memorized. You got to memorize these graphs. So let's see if that kind of fits the bill here. Where would 30 degrees be? If that's 90 degrees, then this would be about 30, be about right here. And let's see if that makes sense, that that's about 0.5. And it does. And so we can see that the value of the function is the distance from here up to the curve. So the sine of 30 here is 1/2. The sine of 90 is 1. The sine of 180 is 0, and so on. So you can see that from the curve. And you should be able to do that analysis yourself. Without a calculator, just make a quick sketch and answer all those questions. Now let's take a look at the cosine. Get rid of this one, and we'll do the same with the cosine, but this time you should be able to answer more of the questions yourself. The cosine of x, f x equals cosine of x, so let's graph that. Now let's see how we can kind of help ourselves remember it, because we have some of them memorized already from our chart. Now we know the cosine has a positive and negative one maximum and minimum. And then we have our pi over 2, our 3 pi over 2. To me, this picture is the best thing. You might like to memorize all this stuff. I hate memorizing. So what I did was just remember this picture in your mind, and you can see those results. So let's see. Now we do know that the cosine of 0 is 1. The cosine of 90 degrees we learned was, and that kind of gets you started because you know it's a nice smooth curve. So this is going to be over here. This will be over there and up here. And that kind of gives you an idea of where you get your sketch, and depends on your skills at making a smooth curve. That would be, kind of cheat here a little bit. So that would give us our cosine curve. Now you answer all those questions for this curve. Look at it and decide for yourself, where are the maximum minimums, where is it increasing, where is it decreasing, and so you can find that out. And this would be our quadrants again. You don't need to put these in, but it kind of helps us because up to this point we talked about the different quadrants then, because we related it to a right triangle. We've left the world of right triangles now, and so we're looking at it as a total function. So let's see, where is it increasing at? I'm not going to write it all down, but it's here. It would be from here to here it's increasing. Where is it decreasing at? From here to here. Where is it positive? Well, it would be the first quadrant and the fourth quadrant. And where is it negative? Down below the x-axis here and here, so it's negative in the second and the third quadrants. And the minimum is a -1, and the maximum is 1 at 0 and at 360 or 2 pi. So we can quickly analyze that, and you should memorize this. You should be able to just be able to walk into and sit down and make this sketch, and then you can do your analysis from that. Let's do the third one. third one would be the tangent. Now the tangent, let's see what that's going to look like. Now the tangent's a little bit harder in my mind. It's not that nice smooth curve. So this is going to take a little bit more. But I do know a couple things about the tangent. It's at 0 here. At 90 we learned it was undefined. So there's going to be an asymptote line here. And at 180 it's 0. And it's undefined at 3 pi over 2. So that kind of gets our start. And it's 0 back at 2 pi. So now you got to figure out kind of how to make it look right. So it's going to look like this. Now answer all those questions for the tangent function. The tangent function, where is it positive? First quadrant and third quadrant. Where is it negative? Second quadrant and the fourth quadrant. I didn't put the quadrant lines in and get mixed up with the asymptote lines, but that'll tell you where is it increasing at. Think about that a minute. Which quadrants does it increase? That's right, it's increasing everywhere. And where does it decrease at? It doesn't decrease anywhere. It's an increasing function. You might kind of wonder, and my mind thinks this too, what happens between when it hits here? It's infinitely large and then all of a sudden it's infinitely small, like it went around somewhere, but there's no place, because it's undefined there, whatever happens there, it doesn't decrease there. So it's always increasing. And what's its maximum? The maximum is infinity and negative infinity. So it's kind of an interesting function that way. And so you've got a picture of that function. Now I'm not going to, I don't think we have to worry about the secant, cosecant, and cotangent, but I do want to look at one of them just to kind of give you an idea of how you can think about it. But these are the three that I would memorize and to be able to just make a quick sketch and do your analysis about the problem. So let's take a look at the, just one of those odd ones. Let's look at the cosecant, for example. Now we learned that the cosecant, how's that related? The cosecant of x is equal to 1 over the sine of x. So we can kind of use that for our model. Now this is how I would do a lot of problems later on. I know how to make the sine curve. We already did that. So let's see, could you make a quick sketch of the sine curve? I'd put the 2 pi, the pi over 2, and the 3 pi over 2. Put the 1, the negative 1. And now I'm going to kind of make just a little dotted line for this. It's got to hit here, there. Let's see, we got to get this right. It's got to not hit there, here, and here. So we got to go. So that's our sine curve. Now let's get real smart here. We're going to make it dotted so it doesn't look so like it's the thing we wanted. It's just our guide. So now think about it a minute. I love this analysis. I wish I had time to really force you to do this analysis, but I don't have that luxury. So let's just really think about it. How are we going to make the cosecant function? What's it going to look like? We don't know much about it. We haven't got a table memorized about it, but what could we do? Well, we do know that the cosecant is the reciprocal of the sine. So right here, what is the value for the sine? 0. So if you put 0 on the bottom, what happens to the cosecant? It's undefined. So we know there's going to be an asymptote line here. Now here there's going to have to be another asymptote line. And here there'll have to be another one, because those are places that the sine's value is 0, and if you divide by 0, it's undefined. So I think that's pretty neat. Now where is the other one we could kind of get a fix on? Well, what about this value? What is the value of the sine here? It's 1. So if you put a 1 there, what happens? 1 over 1 is equal to 1. So that means the cosine, or the cosecant, has to have a value of 1 there, and likewise negative 1 there. So that kind of gives you an idea that the cosecant, and And that's kind of an oddball. You don't have to memorize this, but if you see it, you should say, oh yeah, that makes a lot of sense. Because the reciprocal of 1 is, a negative 1 is 1, positive 1 is 1, and the reciprocal of 0 is undefined. So this is how our cosecant. Now you could do all the maximum and minimums with that, but that I don't feel that that's important. The key thing is maybe able to make a quick sketch of the sine, cosine, and tangent from 0 to 2 pi. Now let's actually go over to the calculator and do a calculator version of this, but I wouldn't depend on the calculator, but it's a good backup. So let me go over to the calculator and take a look at that. First we got to turn it on. Now the key thing in the calculator is figure out everything we did for this picture, the domain and the range of it. So we're going to press our window. And let's see, we've got, we have to have a minimum of 0, so we'll go to 0. A maximum on the x was 2 pi, so we're going to actually put in 2 pi. But now when we hit the next one, it's going to change that. Our scale is where we put our dots at. So our dots we got is pi over 2, so I'll put pi over 2 there also. Pi divided by 2. And then we'll go down to the minimum. For that, the minimum was a negative 1 for the sine. The maximum was a positive 1. So let's go a little bit higher than that. That's going to be right on the edge. That won't look very pretty. Negative 2, and you got to make sure you use a negative. I almost made that mistake myself. And so then I'm going to use a positive 2. My scale I'm going to use is pi over 2. Whoops. Pi divided by 2. So now I've got my window all set up the way it should be, 0 to 2 pi. And then my scale is pi over 2, so we'll put a dot on the x-axis. Oh, on this axis, we don't really want it to be that. Well, it's another mistake. So we can just use 0.5 there. That'll be good. And delete that one. So I think we're all set. Now let's see what our y equals. So our y equals, we want sine x. There, we're all set up to graph sine x. We have it, so let's just see what's going to happen here when we do the graph of it. Now see, we got a straight line. Now we got to think, what did we do wrong? What did we do wrong? Because this can always happen. Well, I put in radians. Let's see what mode I'm in. Because we learned about the mode. And there's my problem. The mode is in degrees. So when it doesn't come out the way you want, think, what, am I in the right mode? So we're going to do that, change the mode. Now we're going to graph it again. And that's our nice little sine curve. Now, for example, we can put in the cosine curve real easily now also. So if we put in the cosine curve, and let's change how that looks a little bit. We'll make it a thicker line. So then we'll put in the cosine curve. And now with these two curves, this picture, you can analyze to yourself, for example, where are the two functions equal at? Well, you can see they're equal in 2 spots, but what would those spots be? And you could do that analysis, you could have the calculator do it, or you could realize that it's probably at 45 degrees, and then up here it's going to be in the, let's see, we've got 45, and then where are they? Both positive again. In the last quadrant, they're both negative, so you could do that. But you could figure that out, but that's not in our scope at the moment. So the key thing I want you to be able to do is to figure out how to sketch the sine curve, cosine curve, and the tangent curve right from your memory without having to do it. So I hope this helped. Now try it in the homework assignment that comes with this video, and then you'll see if you can do it from memory. Don't have to look at the video to do it. Try to do it on the homework without looking back, without using your calculator. Thank you.